Okay, in this video we're going to take a look at finding intersections and unions of intervals. So the intersection of two sets, such as the intersection of two intervals, is going to be the set of elements that both sets have in common. In other words, it's where they're going to overlap, and the word "and" is associated with the intersection of sets. The notation for it, for the intersection of two sets A and B, is denoted with this upside down U. Uh, that's the intersection. And it seems weird, but when we get into the notation for union, at least that one makes sense. So the intersections of set A and B, in other words, the elements or items that are in set A and also at the same time in set B, is denoted with this upside down U between sets A and B. So intersections are going to be common when the variable is between two values. So we saw in some previous videos the shading between two values, like shade between 4 and 9 or shade between 2.5 and 4 would be intersections. So the union of two sets is a set of elements that are in either set or both. So as long as it's in one, it counts. So it could be in both. The word "or" is associated with the union of sets. And again, and versus or, if you have to go to the store and buy milk and eggs, then you need to make sure you come back with both items. If you're told to go to the store and buy milk or eggs, as long as you come back with at least one of them, you could come back with both. But as long as you come back with at least one of them, you're not going to get in trouble. So the union of sets A and B uses this U symbol in between, so at least that makes sense. So they just got creative and flipped the U upside down for intersection. So A union B is A with a B with a U in between them. So unions are common with intervals that do not overlap, although they are allowed to. So these aren't written in stone for the unions and intersections, but it is pretty common. So it's the common case that you'll see. All right, so example 2, we're going to write each of the following using interval notation and graph as well. So we have x is less than or equal to 4 or x is greater than 7. So we want values that are either less than or equal to 4 or values that are greater than 7. So let's start with the graph because I think it's easier. So we have 4 and 7 on our number line. If we start with x is less than or equal to 4, the less than or equal to is a closed circle at 4, and then we shade everything to the left for all the values that are less to the left. For x is greater than 7, because it's greater than, we're going to use an open circle and shade everything to the right. And the nice thing about the word "or" is once you graph both of them, you're pretty much done with the graphing part. You don't have to worry about where they overlap or anything. So our interval notation for this, we're going to have for the first one in blue here, 4 and shade to the left is negative infinity with a parenthesis in front of it, and then a 4 with a bracket because of the closed circles. Then we have for the greater than 7, we have parenthesis 7, comma, infinity, and then we're just going to unite them by with that union notation there. So this first part here is in blue for less than or equal to 4, and this part here for greater than 7 is in red, which we have this interval here, and we just unite them when we're done. So just look at one at a time, and you should hopefully be okay. All right, part B, we have x is less than 2 or x is greater than or equal to 9. So once again, we're going to start with our number line, and we have less than 2 is open circle at 2 because it's less than, and shades to the left. Greater than or equal to 9 is closed circle at 9 and shade to the right. And now we're just going to take this first one here in blue. This is less than 2, so that's negative infinity to 2 with parentheses around those. And then greater than or equal to 9 over here in red, we have bracket with followed by a 9, and then comma infinity with always a parenthesis. So remember, always a parenthesis before negative infinity, always a parenthesis after positive infinity. And here's our individual intervals. We just unite them with this union notation. All right, here we have part C, x is between 0 and 5, where it can't equal 0, but it can equal 5. So if we look at our number line, we have for x's greater than 0, we can put that above the number line and open circle where 0 is, and we would shade to the right forever. And then for our second part, we have x is less than or equal to 5. So what this inequality, this compound inequality here means is x is greater than 0, and at the same time, x is also less than or equal to 5. So there's our x is less than or equal to 5. Now, when we bring them down, the open circle at 0 and the closed circle at 5, and then they overlap in between. So the overlap in between, like the values of 1 and 2.7, would get shaded because those values are greater than 0 and at the same time less than or equal to 5. So and this also goes back to our introductory video where we saw with the 4 and the 9, where 4 had an open circle and 9 had a closed circle, and shade everything in between with this set builder notation. For the interval notation, it's parenthesis with the 0 because it has an open circle, 5 has a bracket because it's closed circle, and then we're pretty much done because we have a definite starting point of 0 and a definite stopping point or ending point of 5. All right, finally part D, -5 less than or equal to x less than or equal to -3. So once again, we have for x is greater than or equal to -5, we could start at closed circle at -5. For x is less than or equal to -3, we can have a closed circle at -3. And just like the last example, we're going to shade everything in between those two values. So this means x is greater than or equal to -5, and at the same time, x is less than or equal to -3. So all the values between those numbers on the number line will make this compound inequality true. And then our notation for it, just brackets because of the closed circles. We get bracket -5 and then -3 with a bracket afterwards. All right, that about does it for this video. In our final video for this section, we're going to take a look at how to write interval and graphing for when x does not equal maybe only 1 or 2 or so particular values. So I'll see you then.